Hi there, my name's Ned Stratton. I'm a London-based data analyst working in the events and publishing industry in commodities. I'm also an independent blogger. I write about future work, data issues, and do data visualizations on my blog, predominantly in Power BI. The address of the blog is in the top left of this slide. And on Wednesday, the 26th of January 2022, I gave a lunchtime talk to the meetup group, London Business Analytics Group, on a personal project of mine, which I did just recently, and which has kind of been in the pipeline for a year. I did a data analysis of Google Trends data, comparing coronavirus and coronavirus-related search terms in the UK over the course of the pandemic, and visualizing it in Power BI, producing a dashboard for it, and also showing a technique for how you can cheat the limitations of the Google Trends GUI when comparing more than 5 search terms against each other. This recording, wherever you're watching it, is a précis of the reasons for doing my project, the insights that I found from it, and the processing techniques that I used in a Jupyter Notebook using Python and then Power BI to make it work, and some ideas for how you could reproduce it. So without further ado, let's get into it. Okay, so great. In November 2020, I'm not sure what everyone was doing. We were under a full lockdown, so in kind of a moment of curiosity, looking for new posts to write on my blog, I started kind of daydreaming and brainstorming, and curiosity kind of like led me to, well, when did people stop saying coronavirus, and when did people start saying COVID? So, thinking that would be the trend, listening to news reports, people stopped saying had pivoted from one to the other, presumably because it was shorter to keep referring to COVID rather than coronavirus. So, knowing about Google Trends and having used it before, I did this. I started comparing the two. So let's just start that coronavirus. Obviously, you can put it into the last 5 years, and then I saw like a big spike, obviously around March 2020 when the pandemic first starts. But then if we compare that with COVID, you can see at the time of the pandemic started in the UK in March, coronavirus is the big search term, and COVID is less widely used. But around September, COVID starts overtaking coronavirus in Google search term popularity in the UK, and it's been like that steadily ever since. That answered my initial question. Then I kind of thought, well, is that a lot? What's that in relation to? How does that compare to, say, previous big events in UK cultural life and the UK politics and news over recent times? And so then I thought, well, what have we been talking about non-stop before the COVID pandemic era? Brexit. So I compared it to Brexit, put that in, and as you can see, COVID and coronavirus are both massive compared to Brexit, which really surprised me at the time when I first started researching this, because I thought that Brexit was all that dominated the UK news agenda for 4 years since the referendum in 2016. Actually, if you dial it back all the way to 2004, where Google search data starts, even the spike on the referendum day in 2016 is pretty tiny compared to COVID and coronavirus. But still not quite there, because COVID, coronavirus, and Brexit, they're all news events. People search for things constantly on the on Google, like holidays, famous footballers, and I don't know, porn. I thought that would be a good consistent search term to look at. So I then compared it to porn. So we put porn in. You get, and let's just switch it back to the last 5 year period. you get a pretty constant, solid green line for porn. It's a non-cyclical term. It keeps going. And actually, I thought that's actually a really good benchmark to see the popularity of a certain issue over time. To see how big is it compared to a cyclical search term like porn. It could be something. Could be anything cyclical like holidays. I choose to chose porn. That's where my not my interest lay, but that's the first thing that popped into my head. And this is obviously quite a frivolous example, but you can bring this Google search technique into a more advanced data analysis project, and also look at serious things that you might want to do for a market research project. But what we're going to hit on now is the limitation. Let's say if we want to really search for a lot of terms related to a topic, and let's say this topic is coronavirus. I've got COVID, coronavirus, Brexit, and Paul. Let me take Brexit out for a minute and put Omicron in, which is the name of the latest variant. And Omicron's peaked a tiny bit since it was announced in November, but as you can see, I can only go up to a maximum of 5 on Google Trends. So if I want, and I can download this data as a CSV file, and it will give you the search term points in weekly batches over this 5-year period for each one on a row. And if I wanted to do 5 more search terms than COVID, I then have to do the same process again. And of course, those 5 terms are kind of completely out of kilter. I could be getting 100 points on coronavirus in this CSV export, but in the next one, because it's a scale of 0 to 100, the most popular in the next batch could be 100, but that's not in relation to these 4, so it's kind of useless data. So that led me on to the Google Trends API and using Python to manipulate the data. Luckily, Google Trends has its own extraction API for it to get the data points which underlie this data set. And on GitHub, there's a developer called General Mills's GitHub has written a custom Python library for interacting with the Google Trends API, which makes it much easier. Deals with kind of any authentication and parses all the API data that you do in your API call into a pandas data frame for Python, which makes working with things much easier. And the real kind of trick here is, let me just get back to the is using porn. Porn's obviously a constant in this, and what this data point is showing here along the x-axis is it's showing, as you can see, the tooltip shows that coronavirus is 33, porn is 8, and the others are less than 1. Now, what that means is that if you can see COVID-1, coronavirus 33, it's showing that for every 1 search of COVID, there are 33 searches of coronavirus, and it's also showing that for every 1 search of COVID, there are 8 searches for porn. So what I can do is use porn as my constant. So if I remove all the coronavirus and COVID ones here, and then if we say put, I don't know, Dominic Cummings, and then we'll put Delta for the Delta variant. You can now you can see the spike of Dominic Cummings. You can see the Delta, but what you've got here is you've got 4 Dominic Cummings for every 69 porns, and you can actually mix this with the 5 search terms I just had on earlier, and use the scores for the others against the score of porn to make porn 1 all the time and everything else a ratio of 1, to actually show the 7 or 8 search terms against each other, thereby getting around the limitation of 5 terms in Google Trends. So what we'll do is we'll switch to the Jupyter Notebook now and run through the code to do that. Jupyter Notebooks, for those that don't know, are provided by Anaconda, which is free to, the individual edition is free to download. And it'll take maybe less than an hour to install, and that gives you all of basic Python. It gives you most of the important Python libraries to do data science and any kind of useful data work, like interacting with flat files. It gives you pandas and NumPy for the data science and for virtual data objects, which is good. And it also provides Jupyter Notebooks, which once you've downloaded Anaconda, which installs to your C drive, you then run it gives you a command line proxy, or something that looks like the command line, called an Anaconda prompt. And you can then type into the Anaconda prompt, like you type a command into the Windows command line or terminal, Jupyter Notebook, and that fires up Jupyter, and which you can create a new notebook. And a notebook is essentially it's a coding environment. It's a batch of code that's blocked up, that's broken up into cells. In each cell, you can run a self-standing block of code which outputs something to the output box beneath it. So that's the output of that bit of code. And also, in each cell, you can declare variables which saves to the notebook, and you can use variables declared in other cells that have already been run. So, for instance, in this cell here, by the end of it, I'll have declared and filled up a list variable in my field called main date list. And in the cell beneath the main looping, I'm actually referring to that. And it works but you have to run this cell to set main date list up before running that. So it's a really good way of breaking up bits of code, testing and doing ad hoc analysis and small projects. So the way to use it to do this particular project is, first you would need to install, if you hadn't already, the PyTrends library, which is General Mills, and running this command will install it for you and collect it. That's the output saying it's done that. I've just commented out because I haven't done that. Like I said, with Anaconda, you get most of the important libraries, but you might not get custom third-party ones like PyTrends. But you just install it. It depends on pandas, LXML, and requests Python libraries being installed, but you have that all already with Anaconda. Next, we're going to import the trend rec functionality from PyTrends, which is subchaptered into other modules. It has its own request submodule, so we just need to import that in and import trend request. Import the datetime module to prepare the dates for the inputs of the API calls we're going to set up with PyTrend request. We're going to import CSV so that we can effectively write out the data we've called off into a flat file. And then from time, import sleep. Sleep is a function you can run essentially with a variable of a number, and that number is the amount of seconds. And if you just put sleep in your code, it will basically pause the running of the code for that amount of seconds, which is a good thing to want to do with API calls, because if you call an API too quickly and too ferociously, you risk you might get errors. It's same very similar principle with web scraping. The site might have counter hacking measures in. So with having imported PyTrends, you can then, which we've done here, you can then set up an instance of the PyTrends class with two variables we just need. Again, more detail on this is in the General Mills documentation, but HL equals NGB means the language should be British English. TZ0 means GMT. 0 is that's basically an offset to determine the time zone that you want to apply to the data that you've extracted from the API. 0 is no offset, so Greenwich Mean Time. Right. This is a function I'm going to define, which I'm going to run. Sorry for jittering. Which I'm going to run through a loop of search terms and timeframes to build my database of search terms. And if I'm just going to bring up what the database is going to look like by the end from this file. It's basically just going to be for each day since the start of the pandemic to yesterday, the score against porn as a ratio of search terms for porn on that day in the UK for that date. So for all the terms I've got, and for all the, I don't know, the having 500, probably 2 years now, maybe 750 days since the start, it's going to add up to about 31,000 rows. And I'm just going to check the last time I ran this. So I didn't run this since December the 8th, 2021. So I made a good note of that. Back to the Jupyter notebook. So what the function does is it takes in the constant, which is a search term string is to search constant, i.e. porn. It's going to take in a list of search terms to compare against it, and it's going to take in a date range, which is a text string with a start date and an end date in year, month, day format. And it's going to initiate an empty list and return it out list. Normalizes dividing one thing by the other to get the other as it's dividing x by y, so as to get x as a decimal and y to be 1. Right, I'm initiating query list to be my constant search terms. Actually, constant isn't a string, it's a single item list with that string as the single item. So I'm essentially initiating a list here into query list. I'm adding the search terms to that query list by the extend method. The two lines which interact with the API are here. So I'm going to build a payload of the query list, which is the constant and the terms I'm interested in. Cat equals 0. That means that relates to what is on here. It's web searches. You can no, it's not web searches. You can split the web searches on the Trends API into more detailed items. Putting 0 in there basically says select all categories, which is what I've done. The time frame is the dates which I'll have made. In the UK, GOGP, and gprop is nothing, is blank. That means search terms only. So if we do Salah, I type in here, I only get a search term. But as you can see, I can get topics, countries, and musicians as the gprop. So gprop blank means web searches. Right. So the query df. So that calls the data. This method converts it into a data frame and takes the specific data points from that query to make the data frame. So those two lines run hand in hand. That's the end of the hood stuff. For term in search, what I'm going to add to the data frame against term, because the search terms are the indexes of the data frame, I'm going to divide it by the constant. That's what the lambda expression is doing. Yeah. Then you just drop a couple of columns here. Drop all the values for pawn. Because they're all going to be one. We're going to put them in. We're just going to use a constant line in the Power BI dashboard later to deal with that. Right. Then I'm going to convert the query dictionary to a list, the data frame to a dictionary using Pandas is to dict method, and then I am converting that dictionary into a list of lists, with the sublists in the main lists being the search term, the date, and the score as a proportion of pawn, and then I'm going to extract that. Now that I've got that, so that's going to be the function that I'm going to run as run across the batches and the dates that I've got as variables. And here are the batches that I'm going to do. So I mentioned that the maximum limit is 5. So each batch is 4 or less. Because pawn, the constant, is going to be the 5th one. So I've got 1, 2, 3. I've got about 12 batches to run through there, and they're all stuff related, coronavirus, COVID, and other things related to the handling and the consequences of the pandemic in the UK. So that's herd immunity, which was searched for at Barnard Castle, where Dominic Cummings went to get his eye tested. Got red travel corridor lists, variants, infection rates, vaccine passports, and names of variants such as Omicron and Delta, and also the manufacturers of vaccines as they are approved on different days and search for themselves. So that's a list of lists. So it's going to iterate through that, each one. And in this bit of, so let me just set up and make sure we can run these. So if we just, so run that, trans, run the function, search time. Now the timings, what I've got here is the start date, and then I'm going to be outputting something called main date list, which is going to be one value for a range of a month, because that's the search term range that you need to get daily increments of data. And doing it like that is a good batch rate. It is a good batch rate. Gets you a day's worth of data for each of the search terms, and you can see that they're strings. They're single strings with the start of the month and the last day of the month. So to get that dynamically based on the latest date in my file, which if we have a look is December the 8th. So what I want is December the 9th. So we'll close that. I want December the 9th to the end of today. So what I'm going to do, if I put that as my start date, and it's going to use the datetime library by means of a while loop to go through each day, check if it's the start of the month, and if it's the start of the month, save the end of last month and the first day of last month it's going to append that into main list, which starts out as empty, and then after it's done the appending. So that's what the while loop does. It says if it's one, set the start, have a temp list with just the start date, then add another day to start date, and if it's keep doing it until at the same time at each juncture taking yesterday's month and today's month, and see if there's a change between the two, and if there is a change, add that day, which would always be the last day of the month, because that's when tomorrow's month's different from today's, or the 8th of February or the 30th for the months with 30 days. If that happens, add that onto the temp list, then put temp list in, and do that operation until start date, which you're incremented by 1 each time, is less than less than today, so yesterday basically. What that will give you is a list of month starts and month ends up to beginning from when you want to run the query from, so that in Python datetime format, and obviously we want to convert the Python datetime formats into strings and join the strings into a single string with a start and the end punctuated by a space. So that's what that's going to do. Very quick line of code here. So we check main date list again. It's only given me 2 because I've only got to do 2 months. I've got to do from the 9th of December to the end of December and then the start of January to yesterday. So I've got my list of dates. I've got my batch of search terms. And what I can do is loop through it, populating main list here. So for each batch in my batch of search terms, for each time frame in my 2 time frames here, call the data for that batch and for that time frame and print a message saying that's done so I can check progress. And then at the end, put a one against a row of 1 with the score for pawn against each date. And that's with the list comprehension there against a unique list of the dates that I've got in my data already, and then put that in at the end. So we just run that. There we go. So as you can see, it's starting to iterate its way through the dates and the search terms in my list. This will take, I think, probably about 5 minutes. Yeah, perfect. As you can see, it's run through all the batches from coronavirus, COVID, Wuhan to booster jab, vaccine passport, plan B, Omicron. And you can see two lines for each one for each date range in my list of dates. So if I just do a quick check and run main list to preview the data. So it's showing search term, date time object, and the score against pawn. So what I'm going to do next is I'm going to append this to the file that I just showed earlier. I'm going to stick it on the bottom. So for this, I'm just using the CSV a library that I brought in earlier. I've got a path which I've just formatted with various elements of my internal filing structure to prevent, because I don't want you to see it, but you just replace this with the exact path, and on Windows you split it up by double backslash to escape the single backslash in Python. Obviously on Linux, they're forward backslashes, so you don't need to escape those. This is the file name, so I'm going to make the full file path as the file path and the file name. Then I'm just doing a check for the user to make sure I want to start a new one or append to an existing one, just to make sure I don't append the wrong data for a new project to an old project and mess up. And then if I satisfy my checks, if I do want to go through with it, I'm going to add in the lines to the bottom of the file, which you do with the A argument when opening a file. That reads all the way to the bottom. Create a CSV writer instance or within my file, and then for each row in my main list, which is this, so search term, date, score, I'm going to write a row into that. So just run that. It'll give me the message box saying, do I want to save my data to the existing master file? I've got that to print in bold by this bold syntax, which enables you to format your Jupyter notebooks in a threatening way, which I want. And then that's run. Having saved the file of the Google search terms, let's just give it a quick check. So I've got it open, and it now goes up. It now has data for January 23rd. Let me just take the filter off. It has more than that. It has, all of January's data as well, and it should also have the rest of the data for December, Yes, it does. 9, 10, 11, all the way up to 34. That's brilliant. So you can create that. In addition to this Google search terms data, I've also, to enrich the analysis we're going to do in Power BI, I've got 2 other Excel worksheets which are going to bring into Power BI via Power Query to make the model. We've got a colours and categories lookup, which is basically just all of the 44 search terms from my list of lists in the Python Jupyter notebook. I've got a hex color category for them, which I'm not going to cover. That was for a beta version of the dashboard I made, where I was using a specific visualization where you needed hex color codes to control the colors. Essentially, but I will explain what a hex color code is. It's, if I just color my spreadsheet, get more colors, it will show you the color I've got, and then if I go to custom, it will give me a specific code which describes that color, and all the codes in this grid of different hues and tones have their own one. So this line green, or this nice kind of like purple color that's its hex code for that, and that's a great way to kind of refer to almost bring coloring via code into and propagate that through models and make sure that that dimension always stays that color. That's good. And then I've also categorized, I've got a category for each of theme for each search term. So obviously Pfizer vaccine and AstraZeneca all fit into vaccines, Brazilian variant, South African variant, and further down the list, Omicron fit into variants, and also restrictions and mitigation is every essentially societal and regulatory side effect of the pandemic as it happened in the UK, and also the tools to mitigate it. So tier 1, 2, 3, and 4 is the travel. Got green there again. No, tier 1, 2, 3, and 4 is the restrictions from September 2020 to the January lockdown last year. Obviously lockdown, a big one there. Quarantine, which was initially what people had to do when they came back from holiday, and still do in some cases. And also Scotch egg, which I have up here. I've called that a restriction and mitigation because a Scotch egg was, if you remember, the minimum requirement for a substantial meal to get into a restaurant and be able to drink under tier 2 when the tiers were live. And thankfully that is now not the case. I don't like Scotch eggs that much. And the other supporting spreadsheet for the model is the events timeline, which in the model I'm going to enrich and show events as they happened in comparison to the search terms being looked for. It's a simple timeline that I've put together with key events from the pandemic, such as the first COVID death in Europe, infection milestones being exceeded, the announcement of the photo scheme, and Captain Todd Moore getting his fundraiser to 32 million and then dying sadly shortly a year later. So here we are in Power BI. I've just refreshed the data sources to get up to January 2022. This is the first visualization I've gone with to show the search terms over time from over 2 years, and I put a slicer in so that you could filter some of them and not have others, so that it's not too cluttered, because we've got one line for each search term effectively. So at the moment we're just looking at coronavirus and COVID, with the purple constant line being pawn 1, so you can see, like we saw in the Google Trends graph earlier, just how high coronavirus is and when COVID overtakes it. What I've got here is a bit of a dirty workaround. It's a single unit bar chart. So each of these is one, and I've taken the x-axis and the y-axis off it, and I've sized it up so that it's the same width and start and end as the dates on the Google's on the search terms axis. So 19th of July match up to 19th of July. And these are the dates. These are the events, remember, from my events lookup. So essentially I've just got just have a look into what this is. It's date from the events timeline, which is on the x-axis, events on this day to show on the tooltip, and then which we'll just bring up now as an example. There we go. So the 2nd of December 2020, the Pfizer vaccine being approved. That's on the tooltip, and the counter event is always going to be 1. So that means they're always going to be the same height, which is good as a workaround. And I can size this up and based on to be from the start from the end, and then I'm sizing this up to be exactly the same as that, which is from the same start as the end. The date is being taken from the events timeline, which is good. So that's purely. Is that true? The date is being. The date's not being taken. The dates are being taken from the events timeline, but the axis is being set as a minimum and a maximum from min date 1, which is a measure in the searches rolling file, and there's also a max to do the max date. And basically, the min date 1 is basically saying get the minimum date from that from this table, which is the searches, but from all that table. So ignore any filter context on that. So that will always evaluate to the same thing because of the all, and same for the max controlling that. This one as well. So it will stretch it out to. It will stretch the timeline out to always be that. And this is, I believe, this is doing the same. It's taking the it's taking from min 1 and max date, so that I know they're always going to be the same, and it's not going to change dynamically if I use the slices to dynamically then alter the date, because there's no date after the slice has been changed. So that's good. So it's they're always going to line up. So I can see when spikes happen. I can see any events that are impacting on them. So I'm looking at COVID and coronavirus now, and I'm seeing that they're way above the Paul constant. I can also take them off and have a look at restrictions and mitigations. So I've got one line for each restriction and mitigation, and obvious search term, and obviously lockdown's the biggest one there. And you can see that was when the first lockdown was called. That spike is around when the November lockdown, which only lasted a month, is called, and then that's the 1st of January, when everyone pretty much knew there was going to be a long lockdown from January and then into the early months of 2021. You can see they get more intense each time, because I think everyone's just inured to the horrors of lockdown and what that's going to impact them, and they just want to kind of like see what rules are going to apply this time and what rules aren't going to apply this time, because there was slight change, slight change in each one. We can see, and then we can see other smaller things like green list travel as people start to think about holidays in April. We can see what else is interesting here. There's a kind of green spike for NHS app there. I think that's when it went. That's when it went live in late September. We can also, there's an interesting one on variants as well. So in this light orange, we have Omicron, and then we had, which was more widely searched than variants in general. So Omicron was the first scary variant the biggest scary variant with the 32 mutations that's caused us to block flights from South Africa instantly, and caused all the Plan B restrictions over Christmas. Obviously, for the user, it's slightly frustrating to have to hover over that to get the to get the search term intensity and the date and the event which may explain it. Power BI has a good solution to that with its pulse chart custom visual. The one disadvantage of a pulse chart is you can't split on a legend. So with the line charts, I have I essentially have the search terms on a legend, so I get multiple lines. You can only have one line on each. So what I've done here is I've grouped them up by the groupings in my lookup spreadsheet that I showed earlier. So I've got key events and people, the restrictions and the symptoms. What you can do with a pulse chart is it's interactive, so you can play and it will hover across over the timeline. Obviously, it's going to take a bit of a while because it's 12 months and it's got one data point for each day. So if we just fast forward and fill the chart, and what you can get with this is for all of the search term, the sum of the search term types I've selected, so coronavirus, COVID specifically, but the people, the restrictions, the symptoms, the vaccines, the variants. So anything, MISC is, I've taken MISC as NHS and NHS off because people might just search for the NHS consistently, even though it is relevant to the pandemic. But this is COVID interest in general, and the dots, which are really handy, are the events that I have in my events lookups table. So I've got Boris and announced the first lockdown there, and I've got the third lockdown there. And on this, in July 2020, I've got the easing of step 4 restrictions all the way up to the announcement of Plan B measures. And this actually shows something really interesting. It shows, look at how many of the dots are at the tops of waves. It shows how the sudden spikes are caused by news events. So the news comes and the people react to it. Shows a certain level of engagement and fear among the public from what news is happening and what they're anticipating. And making this with the data that I have is fairly easy. You've just got you've got the date from my date control table. I'll show you what the date control table is really quickly. Again, it's that's the dates, just a calculated table of distinct dates from here, which then you can then use to filter it, and the search terms and the events timelines cross-filter each other. So the dates obviously on the x-axis, the value, the weight, it controls the y-axis. So that's the sum of all the scores in proportion to porn. Event title and events this day are from going to the event title and the description. They're from the events timeline, which obviously is related to the search terms and to the single dates, and they form the dots at the top. So I've got the you have to do a tiny bit of customization with this, because it gives you a date, a title, and a description, and to make it work in my instance, I made the event date basically. I made a text column of the date, and basically just get the first on blank, which gives you that as a scalar value that you can use in a measure. Obviously, I'm using the relationship between the date and the timeline because I need to grey it out to make it many for many. And then the description is a measure. It's basically just the event name, so it's the same measure but just calling back different data points from the events timeline. Let's just show the events timeline really quickly to show you how the columns are working. So the data and the text came from the original import data, and then the date text is I'm just converting that from a date data type into a text data type, so I can use first on blank effectively. And then from those, I'm doing calculate first on blank of the event and calculating first on blank of the date, which when filtered by that will give me the one I want. So that's that's using the pulse chart, which you only have one line of, but it's more more user friendly than perhaps than the slightly cheaty workaround of the unit bar chart and the line chart in exactly the same position. And then obviously once I've done that, I've just refresh the data and publish it to my Power BI workspace, and then I have it embedded on my blog, and I'll keep this running. So thanks very much for listening, and hope you can hope you find a way to use some of these techniques for maybe Google search terms of things that are commercially important to you and interesting. It could be top 10 footballers, top 10 I don't know, album sales by Dire Straits, or Microsoft certification exam. I picked coronavirus search in the UK. You can pick what you want. Thanks very much.